Let's get a little bit extreme here. I'm talking about extreme values. And there are different types of extreme values that we are going to cover, starting off here with relative maximums and relative minimums. A function value, f of a, is called a relative minimum or local minimum of f if there exists an interval x1, x2 that contains a such that x1 is less than x, which is less than x2, implies that f of a is less than or equal to f of x. Well, that is an incredibly confusing textbook definition. What does this actually mean? All right, recognize here that we are talking about y values of a function. Whenever you see the term function value, we are referring to the y's, f of a. So here is what a relative minimum or local minimum is. And again, two different names. I will use them. They mean the exact same thing. Any y value on the graph that is less than or equal to the y values of the points immediately to its left and right. That is going to be a local or relative minimum. A function value, f of a, again talking about y values, is called a relative maximum or local maximum of f if there exists an interval x1, x2 that contains a such that x1 is less than x is less than x2, implies f of a is greater than or equal to f of x. Well, what does this actually mean? Any y value on the graph that is greater than or equal to the y values of the points immediately to its left and its right. That is going to be a relative maximum or local maximum point. Okay? One thing to make note of is that relative maximum and relative minimum values cannot occur at endpoints. Okay? They can't occur at endpoints because you must be able to compare that y value to points that are immediately to the left and right of it. Okay, therefore it can't be at an endpoint. Let's take a look at a graph here to get an idea of what relative max and relative min means. Determine whether the following points correspond to relative maximum or relative minimum values. Well, let's start off with the point A. Notice that the y value associated with point A is less than the y value of points immediately to the left and to the right. If I go to the left and to the right of point A, the y values both go up. Because point A is less than, the y values of point A are less than the y values of points immediately to the left and right, A is going to be a relative minimum. Moving on to point B. Well, we go to point B here, and we notice that the y value associated with point B is greater than the y values of points immediately to the left and to the right. Okay, if I go to the right of point B, my graph goes down. If I go to the left of point B, my graph goes down. That means that point B is going to be a relative maximum. Point C. Well, again, notice that the y value associated with point C is less than the y value of the points immediately to the left and to the right of point C. If I am at point C and I go to the right, the graph goes up. If I'm at point C and I go to the left, the graph goes up. That means that C is going to be a relative minimum point. Moving on to point D, I again notice that the y value associated with point D is greater than the y values associated with points immediately to the left and to the right. If I go to the right of point D, my graph goes down. If I go to the left of point D, my graph goes down. Because it is relatively greater than the y values of the points immediately left and right, it is a relative maximum. Hopefully we're picking up on a pattern here. Here we move on to point E. Notice that the y value associated with point E is relatively smaller. It's a greater negative number compared to the points immediately to its left and to its right. Notice it is less than, the y value here is less than the y value of points immediately to the right and immediately to the left. Therefore, E is a relative minimum. And finally, as you probably guessed at this point, F is going to be a relative maximum. As I go to the left of point F, my graph goes down. As I go to the right of point F, my graph also goes down. Therefore, f is going to be a relative max. Let's talk now about absolute maximum and absolute minimum values. A function value f of a, so again, we're talking about y values here, is called an absolute minimum or global minimum of f if f of a is less than or equal to f of x for every x in the domain of the function. What does this mean? The lowest value of y on the graph. Your global min or absolute min, again, those two words mean the exact same thing. Okay, two terms mean the exact same thing. It just talks about the lowest y value that we have. A function value f of a is called an absolute maximum or global maximum of f if f of a is greater than or equal to f of x for every x in the domain of the function. Our absolute maximum, if you guessed it, the highest y value on the graph. Note, if it is not possible to identify the numerical value of the lowest point, there is no absolute minimum. Similarly, if it is not possible to identify the numerical value of the highest point, there is no absolute maximum. We must be able to place a distinct numerical, a real number value on our highest point and our lowest point if they are going to be absolute maxes or absolute mins. Let's look at a graph here. Identify the absolute maximum and absolute minimum of the function. What is the absolute maximum of the function? Remember, these correspond to y values. What is the greatest value of y on the graph? Well, looking at the graph, it looks like the greatest value of y is 8. Therefore, the absolute max is 8, and it actually occurs in two different locations. It occurs at x equals 2 here, and it occurs at x equals 8 as well. Okay, the absolute max is 8. It happens at two different locations. What about an absolute minimum in this case? What is the lowest y value on the graph? Well, the lowest y value on the graph is -8. Therefore, the absolute min is -8, and it occurs at x equals -8. There is the location. So again, absolute max, absolute min, think about the y values. Those will be your answers, and the location of them we can write as corresponding to their x coordinates. Okay, let's take a look at another example. Identify the absolute maximum and absolute minimum of the function. Starting with the absolute max. Again, what is the greatest y value of the graph? Well, looking at the graph, our y values approach 9 right here. Are they ever going to reach 9? No. That is shown by the open circle, right? That endpoint there is not included. The y values get infinitely close to 9, but it is never going to equal 9. Because we cannot put a real numerical value on that value of y, there is no absolute maximum. I can't put a number on what that y value would be. It'd be something that's infinitely close to 9, right, but not equal to 9. What about our absolute minimum value? Well, here our graph goes down, 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 and you might notice we have this nice arrow, which tells us that this graph is going to continue down and to the right. Our y values are going to approach -infinity as the graph goes to the right. Well, because -infinity is not a real number, there is no absolute minimum either. This graph will continue to go down and down and down forever. All right, let's look at some trickier ones here. Determine whether the following points correspond to relative maximum minimum values, absolute maximum minimum values, or if they are not in extrema. Starting with point A. So, looking at the graph, because it is an endpoint, it cannot be a relative max or min. My only options are absolute max or min. We can recognize that point A corresponds to the greatest y value on the graph at y equals 6. Because this corresponds to the greatest y value, A is an absolute maximum. Let's look at B. Well, is this going to be the absolute max? Definitely not. Is it the lowest y value? No, I have points over here that are lower, so it's not an absolute min. But if we compare point B and the points relative to it, immediately to its left and to its right, point B is less than or equal to the y value associated with point B is less than or equal to the y values of the points immediately to its left and its right. Because the y value associated with point B is less than or equal to the y values of the points immediately to its left and immediately to its right, point B is a relative minimum. Let's move on to point C. Well, notice we have this horizontal component of our graph. Point C, the y value associated with point C, is equal to the y value immediately to the left and immediately to the right. This one's a little bit tricky. Point C is actually considered both a relative maximum and a relative minimum. Remember that in order to be a relative minimum, the y value associated with the point has to be less than or equal to the y values of the points immediately to the left and to the right, which it is. In order to be a relative maximum, the y values of our point have to be greater than or equal to the y values of the point immediately to the left and immediately to the right. And again, we still meet that criteria. Therefore, actually any point on this horizontal component will be considered a relative max or relative min. All right, moving on to point D. Well, it's definitely not an absolute max, definitely not an absolute min, right? If we look at points to the left and to the right of point D, notice that to the left of point D, my y values go down. To the right of point D, my y values go up. Therefore, D is not going to be an extremum. Extremum is the singular terminology of the word extrema. All right, moving to point E. Well, any thoughts on point E? We recognize here that our greatest y value was 6. Point E has a y value that also corresponds to 6. Therefore, point E is going to be an absolute maximum. At the same time, we can compare the y value of point E to points immediately to its left and immediately to its right. The y value of point E is greater than the y value of points immediately to the left and to the right, meaning that it is a relative maximum as well. Okay, point E is an absolute max and a relative max. And finally, let's come down here to point F. Notice that this is an open circle. The endpoint is not included. These y values are going to continue to go down and get closer and closer and closer to y equals -7. However, they are never going to actually equal -7. Because the y values are actually never going to equal -7, this is not an absolute minimum. And it can't be a relative max or min because it is an endpoint. Therefore, F is not going to be an extremum. All right, let's see a couple more examples here. Use the graph of the function to identify and locate any absolute extrema. Well, absolute extrema means the greatest y value. That would be our absolute max, and absolute min would be the lowest y value. Notice here, this arrow indicates that this graph is going to continue to go up and up and up to positive infinity. Therefore, we have no absolute maximum. What about the lowest y value on the graph? Well, over here on this portion, we notice the y values approach -9, but this open circle means that they are never going to equal -9. The y values are getting closer and closer and closer to -9, infinitely close, but not equal to -9. Because we cannot put a numerical value on that, there are no absolute extreme values. This is not going to be an absolute minimum. All right, using the same graph, identify and locate any relative extrema. Well, let's take a look at some of these points. You might notice this point right here where x equals -3. If I compare the y values of the points immediately to the left and immediately to the right, the y value associated with this point at -3, 7 is greater than the y values of the points immediately to the left and to the right. Notice if I go to the left, the graph goes down. I go to the right, the graph jumps down. Because of that, -3, 7 is going to be a local or relative maximum. All right, over here we could kind of go through the same thing. However, notice that if I move to the left of this point, my y values go down, and I move to the right of this point, the y values go up. Therefore, that would not be a local maximum or a local minimum. The only local extrema that I have is this point here at -3, 7. Use a graphing utility to graph the function and locate any extrema. Round to 2 decimal places. Now, this is a problem where you are specifically going to use a calculator, right? I encourage you to use a TI-84. Go into your graphing setup and plug in y equals x to the fourth minus 3x squared plus 2x minus 1. And you will end up with an image that looks like this. Nice looking polynomial. All right, let's identify the absolute maximum. What is the greatest y value on the graph? Well, it is implied here that this graph is going to continue to rise to the left and continue to rise to the right, all the way up to positive infinity. Because positive infinity is not a real number, I am not going to have a greatest y value. And if I can't put a number on my greatest y value, I have no absolute maximum. What about the absolute minimum? What is the lowest y value on the graph? Well, looking at the graph, it looks like the lowest y value occurs right here. Now, to calculate that point in your calculator, you are going to hit second trace, that's your calculate function, and you want to select minimum in this case because this is a minimum value. It will ask you a couple questions. You need to select a point that is to the left side of that minimum, and then to the hit enter, and then to the right side of that minimum, hit enter. Hit enter one more time when it says guess, and it will spit out the ordered pair of that point. In this case, the ordered pair for our absolute minimum is going to be -1.37, -5.85. That is the lowest y value. That is the point corresponding to the lowest y value on the graph. The absolute minimum is -5.85, and it occurs at x equals -1.37. What about relative maximums? Again, relative maximum is any y value that is greater than or equal to the y values of the points that are immediately to its left and to its right. Looking at the graph, it looks like I have a relative maximum occurring right about here. Okay. Notice if I go to the left of this point, the graph goes down. If I go to the right of this point, the graph goes down. Relative to points immediately to the left and right of this peak, this is the highest value. So I'm going to go into my calculator, select second trace, and in this case, I want to choose maximum. Again, I need to input a point that is to the left of that maximum value. I need to input a point that is to the right of the maximum value and hit enter. If you don't know how to find maximums and minimums in your calculator, I strongly recommend that you do a quick Google search or go into YouTube. There are definitely some great tutorials on how to do it on your particular calculator, hopefully the TI-84. So plugging that into our calculator gives us our relative maximum point. This occurs at 0.37, -0.65. We have a relative maximum of -0.65 that occurs at 0.37. And relative minimums. Again, a relative minimum is any y value on the graph that is less than or equal to immediately adjacent y values? Well, we actually already found one. Yes, this absolute minimum point also corresponds to a relative minimum point. If I go immediately to the left and to the right of this point, my y values both go up. Is there another location where that happens? Yes, right over here. Okay, so again, we need to go into the calculator. Second calc minimum. Select a left-bound point of the minimum, a right-bound point of the minimum, hit enter, and it will spit out our ordered pair of this minimum point. In this case, that second local or relative minimum occurs at 1, -1. There you have your extreme values.